39, determine if the ordered pair is a solution to the system of equations of. Alright, so 1/2 -5, so we'll just plug it in and see if it works out. 1/2 plus -5, that should equal -2, so we get 3 minus 5 is -2, we get -2 equals -2, so at least that one works for the first equation, but we have to check both equations. So 4 times 1/2 minus 3 times -5 should be 17. So this will be 2 minus -15 is equal to 17. 2 plus 15 is equal to 17. And 17 equals 17. So this is a solution. The next ordered pair, we'll do the same process, plugging them into the x and y values to see if they are a solution. So 6 times 0 plus -2 is equal to -2. So 0 plus a -2 equal to -2. -2 equals -2. So it works for the first one. Then for the second one, we have 4 times 0 minus 3 times -2 is equal to 17. 0 minus a -6 equals 17. We get 6 as equals 17. That's not true. Is not a solution. 40. Solve the system of equations using the substitution method. Show all work. So we have 2x plus y is equal to 2. I'm going to solve for y first by subtracting 2x from both sides. We'll then plug it into the other equation. So we get 5x plus 3, and we'll replace our y with that x. Set that equal to 9. Distribute the 3 plus 6 minus 6x is equal to 9. And then we'll combine like terms. So 6 minus x is equal to 9. Negative x, when we subtract 6 from both sides, will be 3. X is equal to -3. And plug that back into here. We'll get y is equal to 2 minus 2 times -3. So we get that y is 2 plus 6, or y is equal to 8. And then if we were to put that in an ordered pair, it'd be -3, 8 is the solution to the system. Solve the system of equations using the addition/elimination method. Show all work. So we have 5x plus 3y is equal to -11, and 2x minus 4y is equal to -20. You can see that we have opposite signs on our y's already. So I'm going to find a common multiple by multiplying the top equation by 4 and the bottom equation by 3. So that'll give us 20x plus 12y is equal to -44. And we have 6x minus 12y is equal to -60. And whenever we add these two equations together, we get 26x plus 0y is equal to -104. That's why it's called the elimination method. We have eliminated one of our variables. So we get 26x is equal to -104. Divide both sides by 26, and we should get x is equal to -4. Now we need to plug that into whichever equation looks easier, I'm going to choose this equation. So we get 2 times -4 minus 4y is equal to -20, or -8 minus 4y is equal to -20. Add 8 to both sides, so we get -4y is equal to -28. We'll add 8 to both sides. Sorry, so that should be -12. Then we'll divide by -4 on both sides and get a +3. The ordered pair should then be -4, +3. 42, solve the system equations by graphing round to 3 decimal places if necessary. So first thing first, we're told to use the graphing. That would be the graphing capabilities of our calculators. So we're going to need to put our equations into a y equals form. So we have this 2x plus 5y is equal to 22. We'll have 5y once we subtract 2x from both sides, and then we'll divide both sides by 5. So we'll get 22/5 minus 2/5 x. So that's one equation that we'll put into our calculator. And do the same thing for our second equation. So subtract 4x from both sides, we'll get 17 minus 4x. Divide both sides by -3, so -17/3 plus 4/3 x. And that's our second equation. Put those into the y equals button for y1 and y2. We'll then hit second, the trace or calc. /calc will be, then scroll down to intersection. It'll ask first curve, second curve, and the guess. So we'll select line 1 with the first curves, line 2 with the second, and then the guess. You should be able to see the intersection point on the graph itself already. Make sure the little blinking dot is by that, and it should get to an answer. The particular answer should come out to be 5.808 when rounded, 2.077. All right, 43. Solve the following system of equations. We can do this in any way that we want. So this first one is set up really nicely for substitution for the x. So we'll do this to substitute this first one into the second one. So 2, whatever our x equals, so 5 minus 3y plus 6y is equal to 10. Distribute that 2, so we get 10 minus 6y plus 6y is equal to 10. So we get 10 equals 10. So with that, that shows that we can pick any x because this is a consistent solution. So if we were to do an ordered pair, it'd be x. Then we need to have some sort of expression for y that depends on x. So that means we would solve for this equation for y. So x equals 5 minus 3y. Subtract 5 from both sides. And then we divide by -3 on both sides, so we'll get -x plus 5 over 3 is equal to y. So our ordered pair is actually infinite solutions, but it follows this rule of select any x you want, and this will be the corresponding y value. Part B, I can see with the x's here that we're starting with something that looks relatively easy to do an elimination method. So we'll write both of these here. Minus y is equal to 2. Negative 9x plus 3y is equal to 4. So I'm going to multiply this top one by 3 and then write it down here. So we'll get 9x minus 3y is equal to 6. And then whenever we add them together, we get 0x plus 0y is equal to 10. So that means there's actually no solution. And if we go ahead and actually solve for our just a y equals function, we should get, we'll get 3x minus 2 for one of them, and then we'll get y is equal to 3x plus 4/3. So this shows that they are parallel lines. And as such, there are no solutions because they will never cross. So then C, we have 5x minus 4y is equal to 6. Negative 3x plus 7y is equal to 1. I can see that there's opposite signs on our x values here. So that's what I will be using. I'll be using the elimination method. So we'll multiply this top one by 3 and this bottom one by 5. So that top one, when we multiply by 3 on everything, we get 15x minus 12y is equal to 18 minus 15x plus 35y is equal to 5. Add them together, we get 0x is what we want, plus 23y is equal to 23. We'll divide both sides by 23 and find that y is equal to 1. I'm then going to use this second equation to solve for our x. So negative 3x plus 7y, which we found out to be 1, is equal to 1. So we get negative 3x plus 7 equals 1. Negative 3x is equal to negative 6 when we subtract 7 from both sides. X is equal to 2, so the ordered pair here will be 2, 1. All right, determine if the system of equations in question 43 are consistent, inconsistent, and dependent or independent. So from that, we can look at the solutions and notice that our solution here is consistent, meaning that there is a solution, but that's dependent upon a choice in x. So equation A is a consistent and dependent solution or set of equations. B, they are inconsistent and each line is independent of each other. So inconsistent, meaning no solution, and independent, meaning they're not the same line. And then C, we get to a fixed point, so that means it is consistent and independent. Meaning it doesn't rely on some other solution. All right, use a system equation to solve the following. The average of the electrician's hourly wage and the plumber's hourly wage is $33. A contractor hires an electrician for 8 hours and a plumber for 5 hours of work and pays a total of $438 in wages. Was the hourly wage for the electrician and the hourly wage for the plumber show all work. So we'll have E being the electrician's wage plus the plumber's wage, divide by 2 will be $33. And then the total cost will be 8 times the electrician's wage plus 5 times the plumber's wage should equal the 438. So I'm going to multiply this side by 2, so we'll get E plus P is equal to 66. We'll solve for P. P is equal to 66 minus E. We can then plug that into here and be able to start solving. So plus 5, 66 minus E, 438. E will distribute the 5, so that'll be 330 minus 5E is 438 still. We'll combine like terms. So you get 3E plus 330 equals 438. Subtract 330 from both sides. We'll get 108. Divide by 3, and we'll get $36 per hour for the electrician. And then we can plug that value back into here. So P is equal to 66 minus 36. P is equal to 30. So the electrician is 36 per hour, and the plumber should be 30 divided by hours. All right, 46. Solve the nonlinear system of equations of that using substitution method show all work. So we'll have 2x plus y is equal to 5. We'll solve for y, 5 minus 2x, and we'll plug that into the y squared. So x squared plus y, 5 minus 2x, quantity squared, is equal to 50. We'll expand that out. Remember that this is two binomials, so this would actually be 5 minus 2x, 5 minus 2x is equal to 50. X squared plus be 25 minus 10x minus 10x plus 4x squared is equal to 50. Let's collect like terms, so we get 5x squared minus 20x plus 25 is equal to 50. Now we have a quadratic. We'll solve that by getting the one side equal to 0. 5x squared minus 20, so we'll subtract 50 from both sides. Minus 25 is equal to 0. See that they can all be factor, or 5 is a factor of all terms here. So we can then divide to just find the zeros of this equation. So from here, we can see we'll get x minus 5, x plus 1 equals 0. So x is equal to 5 or negative 1. With that, if you don't immediately see it, the quadratic formula will pop those two values out as well too. We then need to plug both x values into here to get y. So whenever we plug in 5 into here, we get that y is equal to negative 5, and then whenever we plug in negative 1, we get 7. So those two are paired together, and those two are paired together. So in the ordered pair, 5, negative 5 is a solution, and negative 1, 7 is another solution. Solve the nonlinear system of equations using the addition/elimination method should all work. And then we have an instructor note here that should be a negative 15. So x squared plus y squared is equal to 17, and it is set up nicely for elimination. So if we add these two together, we get 2x squared is equal to 2. X squared is equal to 1. Take the square root of both sides, so we get plus or minus 1. We can then plug that into either one. I'll use the first equation. So whenever we plug in positive 1 squared plus y squared equals 17, we'll get y squared is equal to 16. Y is equal to plus or minus 4. So that means from our x equals positive 1, we'll get positive 4, and whenever we have positive 1, it's negative 4. Now whenever we plug in negative 1 is equal to 17, we square it, 16 again, and then y is equal to plus or minus 4. So negative 1 also gives us a positive 4, and negative 1 gets a negative 4 as well too. Use a nonlinear system of equations to solve the following. The sum of the squares of two positive numbers is 29. The difference of the squares is 21. So the squares, so x squared plus y squared, the sum of the squares should be 29. And then the difference of those squares will be 21. See that this is easily set up for elimination. So we get 2x is equal to 8. X squared is equal to 4. X is equal to, our math says plus or minus 2, but we only want the positive value. So x is equal to 2. So then we can plug that back in. So 2 squared plus y squared is equal to 29. 4 plus y squared is equal to 29. Y squared is equal to 25. And then y, the math says plus or minus 5, but again, we only take the positive values, so 5. So the two numbers is 2 and 5.